Hey, hello, and welcome to the show. I have weird cameras going on. Whoa, hey, whoa. Hello. Hi, it's me, JP. Welcome to JP's product pick of the week. It's Tuesday, so it's time for us to look at a new product pick, don't you think? Before I do anything else, I want to send you to a place where you can get a humongous discount. So head on over to this URL right here, this one, or go to that QR code, and that is going to take you to the product page where you're going to find our product pick of the week, and it is 50% off. In fact, I'm going to head over there right now, and you can see here's the cached version of my site. I'm going to reload that, and hey, bam, 50% off. So head on over there. I know that that's a bit of a spoiler. Now you know what it is, but shh, let's pretend that you didn't. In fact, what I'm going to do is I'm going to reach back in time and ask Mrs. Lady Ada to tell us all about today's product pick.
This is the AMG8833. This is a kind of neat sensor. This has actually been around for a while, but the price recently dropped to a reasonable amount. So this is the an 8x8 thermal array, like basically mini camera. So you can get cameras in the shop that are like 200 pixels by 100 pixels, and you get like a real thermal camera, sometimes called FLIR cameras. But they're really expensive, and also you can't necessarily integrate them into your project. They might be, well, first off, they're expensive and delicate, but second, they usually need like a high-speed interface. Sometimes they're USB cameras. What's nice about this is it all works over I2C, so it's very easy to add to any microcontroller or microcomputer project. And we have example code for both Arduino compatibles and Raspberry Pi. So this is the sensor, and you can see this is like the little lens. We have level shifting and power regulation. The lens is right in the middle. It looks like it's offset, but that's because we wanted to put the lens in the very center. And here I have it just connected up to my Metro, it's just Arduino compatible. And I hooked up 1.44 inch 128 by 128 pixel, and I just have each of the sensor outputs connected, basically outputs to a block. Now, when you read from the sensor, it gives you a 64 point Celsius measurement in floating point. But we just basically map that to some colors and put that here. What you're seeing, actually, this red dot is actually the camera, because the camera is actually a little bit hot, so you see a little bit of a red dot. So you can use this with Arduino, and you get 8x8 grid. It's pretty good. If you're willing to use a Raspberry Pi, or actually probably just a more powerful microcontroller, you can use the filtering capabilities that are built into Python using SciPy to do bicubic averaging. And so you take the 64 points, but you can turn it into 124 points. So you can get a lot higher precision if you can move your fingers, and you can actually see individual points. And actually, what's neat is you can see above both the camera and the line here is the lights, the fluorescent light above.
I wonder how far I can get away where it still says
No, you're hot.
This is why MOSFET the cat will not leave me alone, because I'm warm and he just uses me as a heating pad.
You're super warm. Next up, this is the revision. This is the AMG 8833. So we've had this thermal camera for a while. Now the thermal camera just has a STEMMA QT connector, so you can plug and play it with any of our STEMMA QT interface boards, including the CyberDecks we're about to show. Or, if you've got a clue board, you can plug it in and then have make a little thermal camera. But yeah, it's the same chip, the same schematic. It's actually even physically the same size. We did rearrange the pins a little bit to make them in our STEMMA QT standard. And of course, they have the plug and play connectors on the end to make easy thermal camera projects.
Aha! Hey, that's right. So you know what I'm going to do? I'm going to first turn on my mic, which I have, and now I'm going to head over to my mystery cabinet of wonderful things and pull one out of the drawer. I'll be right back. So the product pick of the week is the AMG 8833 infrared thermal camera. And what I'm going to do, I've actually got a couple of demos I want to show you. So what I'll do first is I'm going to switch to a down shooter. I only have one of them and it's plugged in right now, so I couldn't hold one up in a nice convenient fashion yet. But I think you won't mind once you see this super cool demo. So here you can see I have a Pi portal, and I'm running an Arduino code or Arduino sketch with the AMG 8833 plugged in over I2C. It is using its 8x8 infrared sensors to measure the temperature using infrared of objects in front of it. And then this program is actually interpolating that to the 124 pixels. So you can see we get, thanks to this kind of averaging by cubic interpolation, we get a really cool sort of predator thermal vision look at the world. You can see pretty clearly me waving my arms here. As I get closer, of course, it'll detect the heat getting closer. So there's my face. You can see my forehead is the hot part at the top, my mouth down below. Eyes, especially with my glasses on, they're kind of cold. If I take off my glasses, you'll see that little spot show up. Glasses off, glasses on. And this is, like I said, running some Arduino sample code that's actually in the example codes with the library. So if you get one of these, you'll see all I have here is it's plugged in over the I2C using Stemma QT to Stemma cable. The 4 ports on the side there of the Pi portal work well. The example code is actually for a lot of different boards. You can use this with Feather boards, Metro boards, any of the Arduino boards really. This one I just modified slightly to work with a Pi portal just because it has the integrated gigantic display. And fast enough processor with the ESP32 running Arduino, we can do this interpolation code, which is pretty cool. You can also do this if you're using this on a Raspberry Pi computer. You also have enough processing power to do that. One of the really cool things that I wanted to show is a separate project which is running on the PiGamer in CircuitPython. So I'll show that in a second. But first, before I forget, what I want to do is I'm going to take a soldering iron. I'm going to turn this on. You'll see it's going to start heating up. And I'll get out of the way here and let the thermal camera... Actually, you know what I'll do? I'm going to take the thermal camera and I'll point it at this iron here, and you can see there's this real nice hot spot there of the tip of that iron. Let me point this right side up there. That'll make a little more sense. So you can see here's my computer. That's my workstation that I'm broadcasting from. Whoops. That's pretty hot. A regular monitor, LCD monitor, isn't. So off to the right I have some other monitors that they don't have much of a heat signature, but yeah, that soldering iron is red hot there. Now, as Lady Ada mentioned, the code that we have running gives us these 64 spots, each with a temperature readout per, and then we're interpolating that to these color values. But that can, of course, also be output as the temperature values. You could put that on the screen if you want. You can also, as you'll see here with C. Grover's project, I have this very cool, this is a PiGamer, and I have kind of a cool custom sticker on there for a faceplate that C. Grover came up with. So thank you for that, Jan. He's got a Learn guide up on Adafruit Learn system that I'll show you in a second. So what I'll do is I'll swap over to that. And you can see, again, I'm going to use the little plug-and-play Stemma QT to plug this in. Jan's original project used a feather wing version of this same board. Yeah, and that one works really well as a camera because you can point this at things, and what you point at is what you see on the screen. This is a slightly different configuration. So what I'll do is I'll turn this on here, and we get this nice boot up screen. And you can see it's not happy about that soldering iron there. It's exceeding the alarm temperature. So this one's cool because it has the ability to set an alarm value that it'll beep at you if you go over that value. It sets some, these are in Fahrenheit in this case right now. It's telling me right now we've seen a max of about 89 degrees. That's pointing at me probably. Average of 75, minimum of around 60. If I point this just off to the side in my workshop, you'll see this drops down. It's a little cooler over there against the wall. And then point this back at me. And really neat feature on here is some sort of averaging or almost like a normalization that Jan called focus. So if I press this button here on the PiGamer, what it's going to do is it's going to change the range so that whatever the sort of minimum and maximum are, will fill the full color spectrum. So this is kind of cool. Lets us use more of that color range of the board. Oh, I have this sideways. Sorry, there we go. So there you can see me. This is the straight 8x8 blocks. So this is in CircuitPython. It doesn't have the kind of processing power we would need to interpolate without a C library, but we can show the 8x8 pixels, and you can see it runs really fast and smooth. And this also has a histogram. So if we switch over from image to histogram, we get these sort of graphing values of where we're seeing more of the screen fill up with a temperature. So a small section of the screen would not create as big a bar as most of the rest of the screen being filled or the camera sensors being filled. So super cool couple of implementations there of projects using this great little sensor. What I'll do now is let me switch over to show you some stuff related to the board in my browser. So here you'll see this is the product page, and this is product ID 3538. If you head there now, you get this for 50% off, which is a great deal. And then if we go and take a look at the Learn Guide for this, this will give us some info about the pinout. You can see you can still use the header pins if you want to plug this into a PermaProto board or a PCB or a breadboard, or you can plug into these little STEMMA QT connectors like I've been doing and use it over I2C. And then there's instructions in here for using it in Arduino, in CircuitPython, as well as Python if you're using it on something like a Raspberry Pi. If we head over to the downloads page of the Learn Guide, one of the things you can download is the datasheet. So this is all of the details that you could want about the chip, as well as operating ranges and things like that, mechanical considerations, specifications. The interesting thing is that we've got some really great Learn Guide projects for getting started. So here's one very similar to the code that I was just running that uses a TFT feather wing, a feather, and the sensor to do a thermal camera made by the Ruiz brothers with a really cool 3D printed case here. Here is the Learn Guide that C. Grover created that that I was showing before. There's an earlier version of the sort of stickers to let you know the functionality. And this will take you all through the setup, as well as details on the code and some converters and helpers that are being used. And here's another project, really cool. This one is a monster mask where the eyes will follow you, because one of the interesting things about this module, unlike a traditional PIR sensor, is it can tell positioning within the grid. Since it is a series of 8x8 sensors, there's a notion of positioning within the space of that sensor's field of view. So moving left to right in the sensor, these eyes will track you because it can tell that you're moving left to right. One other thing is, if you head to, I think we might have a link to this, otherwise if you just Google the grid eye, that's what Panasonic calls this, they have some great info about the sensor, including I didn't realize this is one of the main applications, if you look at this image here, is placing the sensor on the ceiling, and it has a 60-degree field of view. There's a little lens in front of all these elements, so you can get a pretty wide spread of positions of heat sources, which is really useful today for things like counting how many people are in a space and even telling how close they are. If people are closer than 6 feet apart, then you might have an issue depending on where you are, if there's masks, how much immunization is going on. So really relevant today. And while it can tell the distance of a person coming towards the sensor like I was doing in my demos, I think one of the more intended applications is this overhead view where you have a fixed distance unless people are jumping up in the air. Pretty much you know the height of people from the sensor, and then as they move around like little blobs, and what I'll do is I'll play this a little bit here. You can see.
But also pre-warning customers that the store is all.
Let me go back to
in a room.
here. Turn that volume down. Here you can see here's an overhead of a conference room, and you can see that there are too many people in the space, is what I was saying. And then here's this little people at the grocery store demo with their little heat signature blobs. So really cool. I didn't realize that that was how some of this sensing is done, but it makes a lot of sense, and it's a pretty inexpensive sensor for doing that sort of thing, given how you could set up an array of these and cover a really large store with pretty small modules. So let's see, anything I'm forgetting? Let's see, the range of it in Fahrenheit is 32 degrees up to 176, which you can tell it was really getting angry at my like 600 and some degree Fahrenheit soldering iron tip there. It wasn't going to measure up that high. That's 0 to 80 degrees in Celsius. And then some of the other applications that Panasonic suggests for the sensor, human detection, you can do simple gesture detection. So given that, again, it knows a heat signature, if I switch back, let me show you my camera again here, and we'll switch back to the image mode. Here, I'm going to just hold the sensor there. You can see here's the heat source of my hand. I'm going to get my body out of the way. And you can see my hand, there's my arm, right? So there's my hand passing directionally. So I'm sure you could set up something pretty effective for doing left, right, up, down types of motion detection, depending on how sophisticated you want to get with your software. All the info is there because you get the individual float values from each of those 64 sensors that are packed into the little array. It's tiny too, right? They're all packed in there, and there's a little lens on top of that gives them a wider field of view. What else? Distance detection, of course, we mentioned. It's useful in these types of applications for things like robotics, if you want to avoid rolling over people's feet and stuff like that. Being able to sense heated things is probably a good idea, as well as location detection, like we mentioned. This works over I2C, and it'll work with 3-volt and 5-volt boards. Let's see, anything else? I think that's it. So that is, I'm going to go ahead and shut this off here. Thank you again to C. Grover in the chat for the super cool project. Very easy to get that set up. So there it is. I'm going to swap cameras back over here and remind you again, head on over to this URL if you want to go, and you can watch the live stream inside of there, of course. We're nearly done. But while the live stream is on, and only during this live stream, you can get this 50% off on this super cool sensor. So I think that's about going to wrap it up. So that's my product pick of the week. It's the AMG8833 thermal camera, and it's in convenient Stemma QT format. I'm going to go ahead and pop that onto my little hang tag here and set this on my increasingly crowded Stemma QT board of goodness and great things. Whoa, oh, that one's going to fall. Don't fall. You stay. Stay. All right, thank you so much. I'm John Park. I'm John Park. This has been JP's product pick of the week, and I will see you next time. Thanks, everyone. Bye-bye.